Assalamu alaikum everyone. I hope you guys are well. So today we will be talking about some NUST entry test past paper questions from the mathematics chapter, particularly from mathematical induction and binomial theorem. So let's get started. So let's talk about the first question. Okay, I am going to zoom in a bit. All right. So the first question says NC1 plus 2 into NC2 plus 3 into NC3 plus so on till n into NCn is equal to what? Now you have a sum and you are interested in finding out the total sum in terms of n. So for such questions we need to refer to a few properties. Only then we would be able to make some expressions. So I'll be talking about a few properties. You can just note them down and we'll be using them for some other questions as well. Okay, so whenever you have such a situation where you have R, N, C, R, or let's write it down this way, the way they have written it, R into N, R. Okay. Now this number is 1. This number is same as this number. 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 That is why this number is same as this number. Now in general, whenever you have R into NCR, you can write it as, now we have a general thing here, N into N minus 1 and then R. These are equal, and this is something we know in general. Now, I can write all these again using this thing. So I can write it as n into n minus 1 c1 plus n into n minus 1 c2 plus so on till the last one n into n minus 1 cn. Okay, all right. So what have I done here? I've written all these. How? Using this logic, I know whenever I have RNCR, whenever this number is same as this number, I can write it as n into n minus 1 CR. Okay, this is something in general you need to memorize this. It is a rule. Okay, so using this rule, I've written the question again. And yeah, now let's see how to do it. Now I know in general, I'll write that thing here using a different color. Okay, now we know whenever we have NC1 plus NC2 plus NC3 plus so on plus the last one NCN, this sum of both odd and even coefficients is equal to 2 to the power n. Always remember the sum of odd and even coefficients. This is odd and even, okay? Is basically equal to 2 power n. So if that is equal to 2 power n, can I write this as, I'll take n common and I can write this thing as n minus 1 c1 plus n minus 1 c2 plus so on and then n minus 1 cn. Can I write it as n would come as it is and this thing written in the bracket as 2 power n minus 1? I can certainly write it this way because this is giving me 2n. Here I had n's. This underlying thing is exactly like this one. The only difference is that here I have 2 to the I have n minus 1, right? So when I have n minus 1, the power would become n minus 1. So this is going to give me n multiplied by 2 to the power n minus 1. So the answer is going to be C in this case. I know this is a bit complicated question. That is why we are spending this much time on this. But it is important. So I'll repeat it one last time. This is your question, okay? This is your question. You need to find the sum in terms of n. Now you need to understand a few things. For these questions, for the questions belonging to mathematical induction, we have a few rules. For example, the sum of both the odd plus even coefficients is equal to 2 to the power n. We'll be using this again and again, so it's important you can just memorize this. The sum of odd plus even coefficients is 2 to the power n. Then whenever you have something of this type where you have r n c r, this number is same as this number, you can write it this way. So since for this one, same thing was happening. So I just replaced the original question written in black with this orange line using the rule written with the red color. Okay. Now, when I have applied the rule, I use this rule that whenever I have NC1 plus NC2 plus NC3 plus so on till NCN, that adds up to give me 2 to the power n. So if I only replace this n with that n minus 1, what would be the change? The change would only be in this n minus 1 and this n. So same happened and I was taking n outside, so I multiplied n here as well, and this turned out to be the final answer, that is C in this case. So that is how we got the first answer. Alright, let's talk about the next question then. Okay, I'll just erase this just so we are able to focus on the question only. All right. Now the second question says you have 3C3, 4C3, 5C3, so on, and then you have in the ending K plus 2C3. Okay. So you need to solve this, and let's see how do we do this. Now for such questions again, we need to use some existing rules, something that exists in general, and you need to memorize this stuff. Okay, so I know this rule: n c n plus n plus 1 cn plus n plus 2 cn plus so on. And this is a rule, I'm not doing it on my own, this is a rule. So then the last term is 2n minus 1. Okay, and then we have cn, and then this thing is equal to 2ncn plus 1. All right. Okay, this is again a rule. I can write it as rule number 2. Okay, rule number 2 is you have ncn plus n plus 1 cn plus n plus 2 cn, so on. This adds up to give you 2 to the power n cn plus 1. Now, why am I using this rule? What is the link? I can see that these numbers are same and this number is same. So ncn, and then we have n's everywhere, and then this number is increasing by 1. So we have 4 here, this is n plus 1. We have 5 here, this is n plus 2. And then this k plus 2 can be thought of as this 2n minus 1. Okay. So for the final answer, we have just added 1 over here, and we have added 1 over here as well. Okay. Now, what is the thing? Now, you need to understand one thing. If we have k plus 2 here, I can write this k plus 2 as 2n minus 1. Now this k plus 2 is basically 2n minus 1, and this is 2n. And to have 2n, I need to add 1 to this thing. So I'll add 1 and this would give me 2n. So I'll be adding 1 here as well and it would give me k plus 3. So one thing is clear, for the final answer, in this case, I would be having k plus 3 c something. So a cannot be the answer, c cannot be the answer. And what about the other part? For the other part, we are also adding 1 here, like this is n and now it is n plus 1. So here it is 3, it would become 3 plus 1, that is 4. So the answer is going to be D in this case. Okay. Now I am used to writing this as notation with C. Like instead of writing n, I write down ncn. So please do not get confused. You should know by now that 3c3 or this thing, like they're exactly the same, it's just the difference of notation, that is it. Otherwise mathematically and the numerical value of both the things is same. Okay, so this was the question on, and for this I have used rule number 2. Using rule number 2, I can clearly see that this thing encircled with red marker k plus 2 is basically equivalent to 2n minus 1, and here we have 2n. We got 2n by adding 1 to 2n minus 1. So when I'm adding 1 to 2n minus 1, I would also add 1 to k plus 2. That give me k plus 3. So automatically a and c options were cancelled. K plus 3 would be there. And what about the other number? This was 3. We will add 1 to this number and it turned out to be 4. So the answer is going to be D in this case. Alright, so let's talk about the next question then. Okay, now it is simple. You have the odd coefficients, and what would be the sum of odd coefficients? Now I'll tell you two rules here. One rule was also shared in the very beginning, that the sum of both odd and even coefficients is equal to 2 to the power n, and then the sum of odd coefficients is equal to the sum of even coefficients. This is also a rule. This is the first one and this is the second one. Okay. The sum of both odd and even coefficients is basically equal to 2 to the power n. And if we divide them, so you would know that the sum of odd coefficients is equal to the sum of even coefficients. So the question is about 1, 3, 5, n minus 1. The question is about the odd coefficients. If in total it is 2n, and if I'm saying they for odd and even it is same, so it would be the half of 2n. And the half of 2n can be written as 2 to the power n minus 1. So the answer is going to be A in this case. Again, for this question, we are using a simple rule, and that rule is whenever you have even coefficients and odd coefficients, you are supposed to that the sum of odd coefficients is equal to the sum of even coefficients, so they would be equal. So I can divide the total sum, that is 2n, by 2 to get the answer, and that has given me 2 to the power n minus 1, and that is A. All right, let's talk about the next question then. Okay, here's the fourth question, and it says the greatest positive integer which divides 11n minus 10n minus 1. Now the number is 11n minus 10n minus 1. This is your number. You need to think of the greatest positive integer which can divide all the possibilities of this number. When I say all the possibilities, it means n can have different powers. Let's say n has the power 0. If n has the power 0, for n equals 0, it would give me 1. Let's say 11 power 0 minus 10 into 0 minus 1, so it would give me 1 minus 1, that is 0. For n equals 1, it would give me 11 minus 10 minus 1 and it would give me 0. For n equals 2, it would give me 121 minus 20 minus 1, that is 100. Okay, and now when you will increase the power of n, you would get a greater number. Okay, now obviously calculators are not allowed in this exam, so whatever you will be doing, you'll be doing without calculator. Now what can you see? So far we got 0, 0 and 100. Now the greatest positive integer which divides this number is what? Now when I will add n equals 3, n equals 4, stuff like that, we will get bigger numbers. Okay, we will start getting bigger numbers, but we need the greatest positive integer that is used for all the possibilities. When the final answer is 0, when the final answer is 0, obviously 0 divided by anything would just divide it. But when the value is 100, and when you will do 100 divided by 200, obviously you won't get an integer, you would get a fraction. The question says greatest positive integer which divides. When it says which divides, it means you must get a whole number. Okay, you must get a number where the remainder is 0 basically, right? So that number is 100, because even when for n equals 3, n equals 4, even when you will simplify this expression and you will get greater numbers, those numbers would be divisible by 100. But for this number 100, you cannot use 200, 300, or this number. You need to have 100 or anything less than 100. You do not have anything less than 100. So the answer is going to be A in this case, that is 100. So I have seen students getting confused with this one. Please be honest with yourselves. If you are not able to understand this question, just comment down right now just so I can answer you there and then. Always remember, for such questions, these are scenario based questions. The value of n could be any. It could be 0, it could be 1, 2, 3, 4, 5, 6, 7, it could be any value. You need to use one number, and that one number should be capable enough to divide all the possibilities. So it should be a small number. Although it says greatest positive, but it should be a small number, because we would also be having numbers like 100. So I cannot say 100 divided by 200 would divide 100 fully. The remainder would not be 0 in that case, right? So the answer is going to be A in this case. All right, let's talk about the next one. Okay, it says if x power 18 occurs in the rth term in the expansion of this, then the value of r is what? All right, let's see. So we are talking about the rth term. So for the rth term, I can think about it this way. We are interested in finding the value of r. So it would be 9 CR 2x power 4, and then n minus r, and then minus 3x power r, and this thing equals something with x to the power 18. I'm only interested in the x term, so I'll simplify this here as well. 4 into 9 is 36, minus 4r multiplied by x to the power r equals x to the power 18. I have forgotten the coefficients. I'm not interested in them. I'll just equate the powers of x. So 36 minus 4r, when bases are same, powers can be added. This is equal to 18. And upon simplification, I am going to get 36 minus 18 equals 3r. R is going to be 6. So when r is 6, the arts term would basically be 1 plus that number. Okay, so it is going to be 7. I'll tell you this concept, students are always confused. Okay, now it says the if x power 18 occurs in the arts term in the expansion, then the value of r is what? Okay, so you are interested in finding out the value of r. The value of r would be r directly, right? And the rth term would basically be r plus 1. So for such questions, you need to understand one thing. It starts off with r equals 0, r equals 1, r equals 2. This is your first term, your second term, your third term. So when it is r equals 6, it would be your seventh term, and r is basically the number of term here, okay? It is not this r, it is the number of terms. So that is why the answer is going to be B, that is 7 in this case. All right, let's talk about the next question. It says, if the coefficient of 2r plus fourths and r minus 2 term in the expansion of this are equal, then what is r? Okay, now we are interested in finding out the value of r, and we know that this and this, like these are two terms and the coefficients are same. Let's compute the coefficients first. So it would be 18c 2r plus. Okay, now what do we know? If it is this term I've just told you, it is one more than the value of r. Okay, if it is, let's say, if it is the r plus 1's term, r is basically r. For example, for the first term, r is 0. For the second term, r is 1. So for 2r plus fourth term, r is going to be 2r plus 3. Okay, and this is equal to the coefficient of the other term, and it won't be r minus 2, it would be r minus 3. I've been telling you already, we do one less than the term. All right, now these two are same and this is equal to that. It means this number is basically equal to this number. Okay, so obviously this number is 1. Even if I incorporate the middle values, that won't make any difference. So it means 2r plus 3 is equal to r minus 3. Okay, and now I can find the value of r as 2r minus r equals minus 3 minus 3, and this would give you r equals minus 6. Obviously r cannot be negative, so you can say that r is equal to 6 in this case, and the answer is going to be A. I'll repeat this question. Please remember, whatever the number of term is, the value of r is going to be 1 less than the number of terms. So if you have 2r plus fourth term, then the value of r for that term would be 1 less than 2r plus 4, so it would be 2r plus 3. If it is r minus 2th term, so it would be r minus 3. Okay, and then upon equating them, I got r equals minus 6. R cannot be negative, so it would be positive 6. So the answer is going to be A in this case. All right, let's talk about the next question. Okay, now it says the number of terms in the expansion of a minus b power 17. So whatever the number is, the number of terms is one more than that, so it is going to be 80. All right. The middle term in the expansion of x plus y power 30. Now we know that if n is equal to 30 and we have n plus 1 terms, it means we would be having 30 plus 1 equals 31 terms. If you have 31 terms, imagine you have 31 terms. So the 16th term would be having 15 terms before it and 15 terms after it, and then this sum would basically give you 31. So 16th is basically going to be the middle term. So that is why the answer is going to be D in this case. It would be the 16th term. So please remember, do not choose answers directly for such questions. That would be 15th. No, just think logically. If n is 30, you would be having 31 terms. If your number of terms is 31, you won't do 31 divided by 2. That would give you a decimal number. You need to think about it logically. Whenever the number of terms used to be odd for finding out the median, we used to have a fixed middle value, right? So it would be the 16th value. All right, let's talk about the next question. Okay, now it says the binomial coefficient of 21st term in the expansion of this is what? Okay, now we are interested in the coefficient. Okay, and for finding out the coefficient, you need to think about it logically. It is the 21st term, so the value of r is going to be 20. So you will do NCR and it would give you 23C20. Now you don't know the value of 23C20 without calculator. You know how to compute it on calculator. But in the previous class, we discussed permutations and combinations, and there I told you NCR is basically n factorial divided by r factorial multiplied by n minus r factorial. So it would be 23 factorial divided by 20 factorial into 23 minus 20, that is 3 factorial. So it is going to give you what? It would give you 21 multiplied by 22 multiplied by 23 divided by 6. So you can just multiply this. Obviously, you will have to. I already did because I wanted to save time. So the answer is going to be 1771. So it would be A. Please try doing such multiplications on your own because you need to understand the oral maths. Like, you need to practice without calculator. You won't be having calculators during the exam. So it is very important that you keep all the rules and regulations of NET exam in your mind before solving past papers, just so you are able to do well in the final exam as well. All right, let's talk about the next question then. Okay, here is the 10th question. It says the sum of coefficients in the expansion of this is, okay, now I've told you the sum of odd and even coefficients adds up to give you 2 power n. Here n is basically 7, so it would be 2 power 7. That can be calculated as 2 multiplied by 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 2. So we have 6 so far and then one last 2. 2 multiplied by 2 multiplied by 2 would give you 8. 2 multiplied by 2 multiplied by 2 would give you 8. And this multiplied by 2. Okay. Now this is 64 multiplied by 2 and it would give you 128. So the final answer is going to be D in this case. So please remember, you need to think about things logically. That is important. Otherwise, you would not be able to solve it. All right. So it would give you 128 as a final answer. And so the answer is going to be D in this case. Okay, let's talk about the next question. Now it says the sum of even coefficients is equal to dash in the binomial expansion of 1 plus x power n. Now you're only talking about the even coefficients. You know the total sum is 2 to the power n, and for odd and even it's equals. You can divide it by 2, and this is going to give you 2 to the power n minus 1. So the answer is going to be C in this case. All right. Let's talk about the next one. Okay, now it says the sixth term from the end in the expansion of this is, now it is the sixth term from the end. This number right here is 11. This is going to have 12 terms. So if it has 12 terms, so this would be the last term, then the second last term, then the third last term, then the fourth last term, then the fifth last term, then the sixth last term. So this would be the sixth last term. The seventh term basically would be the sixth last term. So it is the seventh term. We are interested in finding out the seventh term. If it is the seventh term, r would be 1 less than the number of term, it would be 6. So it would be 11 c6 3 by 2 x power 11 minus 6 and then minus 1 by 3x power 6. So you can find the value as well, but it would take a lot of time. You'll see how I will simplify this. Just look at the x terms. It is x power 5 multiplied by 1 by x power 6, and upon simplification you would get 1 by x. So whatever the answer would be, it is going to have the x term in the denominator, or it would be x to the power minus 1. So just using this much knowledge, I know the answer, because out of these four options only one option has x in the denominator, so it would be D, without any doubt. So this is the best part about the NET exam. As soon as you are sure about a specific answer that this would be the answer, there's no point in wasting your time and doing all the working and stuff like that, because time allocation is the main thing, right? So D is going to be the answer for this one, because my answer would have 1 by x, and this x is telling me that this would be the only answer. All right, so let's talk about the next question. Okay, this is the 13th question. Please try doing this, all of you, because you guys need to practice as well. It says the number of terms in the expansion of a plus b power n, where n belongs to positive integers, is what? Now they're talking about the number of terms, and I've been telling you this thing already. Whatever the power is, if the power is 4, the number of terms would be 5. If the power is 10, the number of terms would be 11. If the power is n, the number of terms would be n plus 1. So the answer is going to be C in this case. All right, let's talk about the next question. Okay, so it is the 14th question, and it says the general term in the expansion of a plus b power n is denoted by tr plus 1. So tr plus 1 is equal to. Now imagine that you are trying to find the general formula for this binomial expansion thing, and we know the general formula is basically ncr a power n minus r b power r. So the answer is going to be A. We already know that we write it down this way because it is 1 more than r. The number of term is always 1 more than r, but that does not make any difference in the general formula, right? The general formula is going to remain the same. All right, okay, let's look at the next question. Okay, the 15th question says the index in a minus b power 17 is. Now the index is basically the power. The power is 17, so the answer is going to be D in this case. Okay. Now it says the sum of odd coefficients in the binomial expansion of a plus b power n is equal to. Now we are interested in finding out the total sum. The total sum is 2 power n, but it won't be the answer because it says odd. We know that the sum for odd and even is same, so I'll divide it by 2, and it would give me 2 to the power n minus 1. So the answer is going to be C in this case. All right. So please, in case of any queries, any questions, feel free to comment down below. I'll answer you there and then. If you're interested in proper course content, you can just get yourself registered using the link in the description box. All right. Let's talk about the 17th question. Now it says the third term in the expansion of this is. Now, if it is the third term, you know, for the first term, r is 0. For the second term, r is 1. So for the third one, it would be r equals 2. So it's simple. The formula is NCR a power n minus r, b power r. Using this formula, I can write down 1 by 3 c 2 1 power n minus r, so it would be 1 by 3 minus 2, and then 6 by x power, it would be n minus r. So it is going to give you 1 by 3. Sorry, it would be this number only. It is n minus 2, so it would be 2 only, obviously. Yes. So this is going to give you 2. Alright. So this number comes here as the power. So this number is coming here. And what do I see? There's no point in simplifying this without calculator. Obviously, this would give you 1. But yes, otherwise it's simple. You can see that your answer would have 1 by x square, or the power of x would be minus 2. Now I only have one choice out of four where I can see 1 by x square. Okay, so the answer is going to be A in this case, because this is the only thing that is making me choose the answer directly. In case if I had two options of this type, I would have said, I would have calculated the complete answer, but since I can clearly see that the answer would be A, so I did not waste my time in calculating any other thing. All right, let's talk about the next one then. Okay, all right. This was the last question. Let's quickly scroll through all the questions we have done today. In case of any queries, any questions, feel free to ask me. Let's start this from the beginning, because in the beginning we had some questions which some of the students find difficult. Okay. So the first rule that we studied today is the sum of odd and even coefficients adds up to give you 2 to the power n. The sum of odd terms only is 2 to the power n minus 1. The sum of even coefficients only gives you 2 to the power n minus 1. Then rule number 2 was this one, that whenever you have such a thing where this number and this number is same, you can write it like this. And using this concept, I just made a new equation and I was able to find the answer as n into 2 power n minus 1. So this was the first question. Then we had a second one, and the rule is written right in front of you. So the last term k plus 2 c3 and 2n minus 1 cn were same. I could see that for the final answer they have just added 1 to this one, so I just added 1 to k plus 2, it gave me k plus 3. And since they added 1 here as well, so I added 1 in 3 and it gave me 4, so the answer was k plus 3 c4. Alright, then again, this was just the sum of odd coefficients, that is 2 to the power n minus 1. I've just told you for the first question. For the fourth one, it was very interesting. It said the greatest positive integer which divides 11 power n minus 10n minus 11 is what? Now, you need to think about a number that would work for all the scenarios. If n is 0, you would get 0. If n is 1, you would get 0. If n is 2, you would get 100. So for dividing 100 completely, you need 10, 20, 50, 5, or 100, right? Like all the factors, out of all the factors, the greatest factor is 100, and so 100 must be used. Any number greater than 100 would not work for this scenario, so that is why the answer turned out to be A in this case. All right, so these are some questions which we have discussed today in today's video. In case of any queries, any difficulties, feel free to ask me right now. Otherwise, you can get yourselves registered for our live classes, which will be starting soon through the link shared in the description box. That is it. then I am going to see you in the next class, inshallah. All right, so take care, everyone.